Welcome, my dear students, to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 3, Normal Distribution, brought to you by Vitan Sir. In my previous tutorial, we studied about the standard normal variable, standard normal distribution, and various forms or the equations we can say of calculating probabilities using the standard normal curve. Let us check out the properties of normal distribution and standard normal distribution. Okay, let's start with properties of normal distribution first. The first property, it is a distribution of continuous random variable. Number two, the constants mu and sigma are the parameters which depict mean and standard deviation. Next, the distribution is symmetric at mu and its skewness is 0. See, in all these properties, there is nothing new which I need to explain. So I am just reading them out. If there is some property which is complicated or new, I will explain. For this distribution, the values of mean, median and mode are equal. We have studied in 11 that symmetric distribution has mean, median and mode as equal values. So same thing, nothing new. For this distribution, the quartiles are equidistant from median, that is Q3 minus M is equal to M minus Q1, and therefore M is equal to Q3 plus Q1 divided by 2. Now once again, this is something which we have studied in 11th in the chapter of skewness for the characteristics of the symmetric distribution. We are just repeating the same things here. We are not doing anything new. The probability curve is completely bell shaped. We have already seen that. The tails of probability curve never touch x-axis. Now remember this thing, never touch your probability curve tails, the two leftmost and the rightmost part to the x-axis. Keep some distance between them because those tails are considered to be parallel to the x-axis up to infinity. The approximate values of the quartiles are, now remember this, you just need to remember them. Okay, there are certain proofs for that, but it is above your level, your current level, 12th standard level, so don't worry too much about that. Just remember this, that if we need to calculate q1, it will be mu minus 0.675 sigma, and if we need to calculate q3, it is mu plus 0.675 sigma. Okay, remember this. For this distribution, the value of quartile deviation is 2 upon 3 sigma. This is an approximate value. And similarly, for this distribution, the value of mean deviation, MD, is 4 upon 5 sigma, which is again an approximate value. These 8, 9 and 10 numbered properties will come in very handy because short question answers, 1 mark questions, 2 mark sums and even MCQs are asked based on these results. So especially remember these values of 8, 9 and 10. Then 11th property, the last one actually, but there are many sub properties in this. Important areas under normal curve. First one, the total area is 1, we know that, and area on both sides of mu is 0.5. Of course we know that thing. Area between the values mu minus sigma and mu plus sigma is 0.6826, that is mu plus minus sigma. The property, the area, the probability is 0.6826. Let's see it in a shape here. This is your curve with central value is mu. So mu plus sigma and mu minus sigma means right side, sigma on the right hand side and sigma on the left hand side of mu. So which will be something like this. So the probability of this area is 0.6826. It's ready made, already calculated using the table. Okay, area between mu minus 2 sigma and mu plus 2 sigma is 0.9545, that is mu plus minus 2 sigma is 0.9545. We can again see the same thing here as right, 2 sigma, 2 sigma on the right and left hand side of the mu, and this is the area depicted. Similarly, area between mu minus 3 sigma and mu plus 3 sigma is 0.9973. So we will write it down like this. The area is 0.9973. That means almost it covers almost the whole curve, almost, because our total value is 1 and this is 0.9973. Okay, so area between mu minus 1.96 sigma and mu plus 1.96 sigma is 0.95. So it will be something like this, a bit less than 2 sigma. And then area between mu minus 2.575 sigma and mu plus 2.575 sigma is 0.99. So the probability 0.99 probability uh, for this area is mu plus minus 2.575 sigma. So these are the ready-made intervals, 5 of the ready-made intervals which will be used, will be, I am not saying maybe, I am saying will be used for asking MCQs, 1 mark and 2 mark short question answers. So you need to remember these probabilities. So basically you need to remember 8, 9, 10 and 11 number properties value very carefully. So these are the properties for normal distribution, and the properties of standard normal distribution are also quite similar because those distributions are almost same. There is only a bit of a difference between them, and the normal distribution is usually converted into standard normal distribution, so they have very similar properties. The first one, it's a continuous random variable. The second one, the mean is 0 and SD is 1. We know that, right, from the previous tutorial. The distribution is symmetric at z is equal to 0 and its skewness is 0 because it is symmetric at mu and mu is 0, so it is symmetric at 0. The probability curve is completely bell shaped naturally, and also in this distribution the tails of the curve never touch x-axis. The approximate values of the quartiles are, now why this, because in the normal distribution it is mu minus 0.675 sigma, but mu is 0 in this distribution and sigma is 1. So writing mu plus or mu minus, that is 0 plus or 0 minus, means nothing, and because sigma is 1, multiplying it with 1 also means nothing. So the quartile values, the Q1 is negative 0.675 and Q3 is plus 0.675. So remember this. Okay, these are the direct values of the quartiles for standard normal distribution. Seventh, for this distribution the value of quartile deviation is QD 2 upon 3 into sigma. Sigma is just 1, so we are not doing anything into sigma. Into 1 means the same value, so we are just removing the sigma here. So for standard normal distribution, QD is 2 upon 3 and similarly MD is 4 upon 5. Okay, so again you have to remember the properties numbered 6, 7 and 8. Next, important areas in the standard normal curve, similar things but a bit different. The total area is 1, the area on both sides is of z is 0.5. Now area between the values z negative 1 and z positive 1 is 0.6826, that is plus minus 1 is 0.6826. Why? Because mu is 0, so mu we are not going to write, and sigma is 1, so sigma is also something which we are not going to write. So it's just the values positive 1 and negative 1, but the area is going to be same. But just look at the symbols here. Positive 1 and negative 1 values are 0.6826. So on the right side we have 1, on the left side we have negative 1, and the area between these two values is 0.6826. Then area between negative 2 and positive 2 will be 9545. So it will look something like this. Okay, area between positive 2 and negative 2. Similarly, area between positive 3 and negative 3 is 0.9973. So its curve will be between -3 and +3, which is 0.9973. Then area between -1.96 and +1.96 will be 0.95. It will be like this. And the last one, the area between -2.575 and +2.575 is 0.99. So these are the properties of standard normal curve or the standard normal distribution. So you need to remember 6, 7, 8 and 9 numbered properties very carefully for this distribution. So actually all of these properties are important for the purpose of MCQs, the 1 mark questions and the 2 mark theory questions and sums, because sometimes 2 marks questions are asked about write down the properties of normal or standard normal distribution, in which you have to write any 4 properties. So the early properties are useful for theory, the later last 4 properties are useful for the sums and the calculation purposes. Okay, so keep these in mind. Now let's start with the sums, the practical sums. You might have been waiting since long for these sums, because without doing practical sums we will not understand how this actually works. So let's start with that. Illustration 1. A normal distribution has mean, tan and SD2. Find the probabilities of number 1, normal variable x taking value between 10 and 12. Second, normal variable x takes value between 8 and 10. Okay. What we need to do first is mu is 10 and sigma is 2, so we need to convert these values of x into z values. I have told you guys many times that we can't calculate probability for the x, we need to convert x into z, and then using z we have to check the values of probability in the table and write down the answers. So what we are going to do, number 1, x has value between 10 and 12. That is, if you write it down in the notations, value of x is between 10 and 12. Always write the lower value first, then x, and then the upper value. So x is between 10 and 12. Now we are going to convert this into our z value. And what is z? Z is x minus mu upon sigma. The mu is 10, sigma is 2. So how we are going to do that? It will be like this. First of all, 10 is written. So 10 minus mu is 10 upon sigma is 2, less than equal to z, because x has been converted into z, and then again less than equal to 12. So 12 minus mu is 10 divided by 2. So when we solve this, we get 0 upon 2 less than equal to z less than equal to 2 upon 2, which will be 0 less than equal to z less than equal to 1. So now this value, if we try to depict in a curve, okay, I'm going to draw curve for each and every question here, because that's the only way to make it simple. So the values are between 0 and 1. Now 0, line for 0 is already available, so I just need to make a line for 1, and this is the part which I need to calculate. Now here is our a part of our table. We don't need the whole table right now, we just need the part of table where 1 is there. Now how we are going to do this? So first of all, just check out these z values here. Okay, these are all the values of z, and what is our value of z here? 0 and 1. But because all the values of z are calculated from 0, we just need to calculate the value of z for 1. So first of all, look at the vertical values. Can you find 1 here? This is 0, 0.0, 0, 0.1, 0, 0.2, 0, 0.3 up to 1.0. So naturally 1 is 1.0. Now we have to check it out horizontally, and in horizontal values you will get second decimal point values here. For example, if our value is 1.01, then we will check it out here. If it is 1.02, 1.03, 1.04, but right now we only have 1, so we can say that 1 is 1.00. What we can say? 1.00. So this value here against this value here will collide at this point. So the value of probability of z between 0 to 1 is 0.3413. So just write it down. So your answer here is 0.3413. Okay, because it is between 0 to 1, so 1.00, 1.00 0, that is 3413. So that's the first question. The answer for first question is 0.3413. Let's move on towards the second question. Now x has value between 8 and 10, that is x is between 8 and 10. 8 less than equal to x less than equal to 10. Same thing, we need to convert x into the z value, which is x minus mu upon sigma. So again we will convert it as 8 minus 10 upon 2 and 10 minus 10 upon 2. We deduct the mean and divide it with the standard deviation. So it will be negative 2 upon 2 and 0 upon 2, which will be negative 1 and 0. So negative 1 less than equal to z less than equal to 0. Now if I depict it using a curve, it will be, first of all I have to show negative 1. Negative 1 is on the left side of the curve naturally. So negative 1 to 0, this is the part which I am going to highlight. Now once again I will take my table out here. Now as you can see in this table, only positive values are given, negative values are not there. But because this is a symmetric curve, it doesn't matter whether it's a positive value or a negative value, the area will be same. If we have positive 1 here, the area of negative 1 and positive 1 will be same. So irrespective of the sign, we will check out the answers here only. So once again we have 1 is 1.00. So once again we will get the same probability, negative 0.3413. Negative will not be there because probabilities are never negative, right? So the probability answer here will be once again 0.3413. That means it doesn't matter whether our value of z is in the negative portion or the positive portion, our answer will always be positive because answer is a probability and probabilities are never negative. Let's check out other sums also. We are going to do 3 illustrations in this question, in this tutorial, and we have completed the first illustration. We will move forward towards the second one. A normal distribution has mean 20 and variance 16. We have to find normal variable x take value less than 26 and normal variable x has value more than 14. Okay, now first of all, mean is 20, variance is sigma square, which is 16. But we don't need sigma square, we need sigma. So we will take a square root. So sigma will be 4. Now sometimes people get confused. They directly take 16 value and do the sum. Don't do that. Variance is 16. We don't need variance. We need standard deviation, which is the root of variance. So root of 16 is 4. So what we are going to use in our calculations are 20 and 4, not 16 but 4. Let's start. X has value less than 26, so x less than 26, just put this value into a symbol. So x is less than 26 and we will convert this into our z value. So when x is less than 26, it will be actually z less than 26 minus 20 upon 4, which will be z less than 6 upon 4, which is z less than 1.5. Okay, now as you can see here, there is only one value available. Let's see what we can do with that. Let's draw the curve. Okay, and put the value here 0 and 1.5. You can see that 0 is in the center and 1.5 is positive, so naturally it is going to be on the right hand side here. And now z is less than, so everything which is less than 1.5 is to be highlighted, but up to where? 1.5 less means left. Everything which is on the left side of the 1.5 will be highlighted up to infinity. Getting my point here? Everything which is less than 1.5, that means it is going up to negative infinity. This whole part has been highlighted. We have to find a probability for this whole part. But now, do you think we can find the probability in a single go here? No, it is not going to be possible because we don't have 0. We have 0 in between here only. So what we are going to do, we are going to convert this single part into two parts. The first part will be this negative infinity to 0. This will be your first part, and second part will be 0 to 1.5. Always calculate probability when one of the values must be 0, then only you can calculate the probability. So right now the first part is negative infinity to 0 and second part is 0 to 1.5, and then we are going to add both of them. So it will be like negative infinity to 0 and 0 to 1.5. Always start writing from the left hand side. So negative infinity to 0 and 0 to 1.5. Now we need our table. Now in this table you can see that infinity is not given, but then again we should know that infinity means 0.5. The whole left hand side part has been highlighted. The value of the whole left part is 0.5. So the probability for negative infinity to 0 will be 0.5. We just need to calculate probability for 0 to 1.5. So we need to find 1.5 in this column which we have here. This is your 1.5, and after 1.5 we have 0, 1.50, because we don't have any other value. So it will be 0 0, 1.5 in 0 0. So 1.5 in 0 0 is 0.4332. So infinity value is 0.5 and 1.5 value is 4332. That would be 0.5 plus 4332. The answer is 9332. 0.9332. So the probability for the given question that x has value less than 26 is 0.9332. Let's move forward toward the second one. X has value more than 14. So x is greater than 14 is what we are trying to say here. We will convert this value into z, which is x minus mu upon sigma. So 14 is less than x or x is greater than 14. We can say either, it's okay. So 14 minus 20 upon 4 less than equal to z, that is negative 6 upon 4 less than equal to z, that is negative 1.5 less than equal to z. We need to draw a curve here. Negative infinity, positive infinity, 0, and negative 1.5 is negative, so it comes on the left part of the curve. And everything which is greater than negative 1.5, what we have to do, we have to do it more than. So everything which is greater means the whole part. So this is what we are going to highlight here. Okay, this is the part which we are going to highlight. Greater than negative 1.5 means up to positive infinity. So how we are going to calculate probability for that? Once again, we will divide this into two parts. The first part will be negative 1.5 to 0. Second part will be 0 to positive infinity, because every time we need 0 in the equation, else we can't calculate the probability. So negative 1.5 to 0 and 0 to infinity. So negative 1.5 less than equal to z less than equal to 0 plus 0 less than equal to z less than equal to positive infinity. We will take our table here. Now once again, infinity value is 0.5 because it's the whole right hand side part, which is 0.5. So we just need to calculate probability for negative 1.5. Now it doesn't matter whether it's negative or positive. We just have to check it out at 1.5 and 0. So it connects at 0.4332. So 0.4332 plus 0.5 is 0.9332. Easy, right? It's not that difficult, because actually we are not doing any calculations. We are just writing down proper equations, proper curves, and then checking out the values in the table. That's all. No, even you don't even need calculus for this, right? Let's move forward towards the third illustration. Illustration 3. The number of students in classes of higher secondary schools of a city follows normal distribution. Average number of students in the class is 50 and its standard deviation. Okay, standard deviation is directly given 15. Find the probability. Number 1, class has more than 68 students, and number 2, class has less than 32 students. Okay, so more than 68 and less than 32. First of all, mu is 50, sigma is 15. We will convert x into z's. X has students more than 68. So the class has students more than 68. So 68 is less than equal to x, or x is greater than equal to 68. You can write either way. It doesn't matter. Okay, so we will be converting this x into z value. 68 less than equal to x. So 68 minus 50 upon 15 is less than equal to z, which would be 18 upon 15 less than equal to z, that is 1.2 less than equal to z. That means 1.2 is the lesser value, z is the greater value. So first of all, let's draw the curve here. Okay, as you can see from the curve, 1.2 comes in the positive part of the section here, so we will write down 1.2, and then z is greater than 1.2. So the question more than 68, that means more than 1.2. So more than 1.2 is right side part up to infinity. So this is the part which we are going to calculate right now, and it does not come anywhere near this 0. But I think you guys must remember that in my previous tutorial I explained an exactly similar kind of example and how to solve that. First, we need to calculate the probability from 0 to infinity, this whole part, and then we need to calculate probability from 0 to 1.2, this part. That two probability we can calculate. So from 0 to infinity we will subtract 0 to 1.2. So this is the part which we will get by subtracting two different probabilities. Let's write them down. First of all, 0 to infinity, and then 0 to 1.2. We will need a table for that. For infinity we already know it is 0.5. For 1.2 we will check out this side. 1.2, 1.2, 1.2. Okay, here is 1.2, and after 2 there is nothing, so 0. So 1.2 value in the 0 column is 3849. So 0.5 minus 3849, we need to subtract, okay, the difference, and the answer is 0.1151. So the probability that class has more than 68 students is 0.1151. The second one, x has students less than 32, that is x is less than equal to 32 students. So we will be converting this x into z, which is x minus mu upon sigma, that is 32 minus 50 upon 15. Naturally we get negative 18 upon 15, which is z less than equal to negative 1 upon 2. We will need a curve here to understand this properly, and because we have negative 1.2, it will be on the left part of the curve, and now z is less than negative 1.2. Less always means on the left hand side, more means right hand side. Here we have less than, so it is less on the left hand side. So this is the part which we are going to highlight here. Now what to do? Because in the previous sum we did the difference, here also we are going to differentiate it. Okay, so 0 to negative infinity, and then 0 to negative 1.2. We will calculate 0 to negative infinity and 0 to negative 1.2 first, and then we will use the table to calculate probability for that. Now naturally negative infinity has 0.5 probability, the half, and negative 1.2 means 1.2 only, and 1.2 in the column of 0 is 3849. So 0.5 minus 0.3849, same answer 0.1151. Don't worry, they have asked questions in such a manner that we get the same answer. So don't worry that why are we getting the same answers. You are not supposed to get the same answers always. Textbooks people have asked the question in such a manner that you get the same answer. So I hope you guys understood it better. Next time we will do some further illustrations, and thank you for watching. Welcome students to Vitan's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.